Gaze upward on any clear night, and there it hangs, Earth's silent, luminous companion, the moon. For millennia, it has governed our tides, inspired our poets, and illuminated our darkest hours. We think we know it, a barren rock, gravitationally captured, a relic of primordial chaos. But what if everything we believe about this celestial neighbour is a carefully constructed illusion? Consider a startling fact. During a total solar eclipse, the moon fits the sun with astonishing precision, a cosmic alignment so perfect it defies statistical probability. Contrast this with the unsettling data from Apollo missions, revealing that our satellite does not behave like any natural body should. These aren't just minor curiosities, they are profound anomalies. Whispers from the void suggesting a truth far stranger than fiction. This isn't just about rocks and orbits, or the cold mechanics of space. It's about questioning the very foundations of our cosmic understanding, challenging the narratives we've accepted about our place in the universe. If the moon is not what it seems, if its very existence points to an intelligence far beyond our grasp, then humanity's history, our solitude, and our future are all radically redefined. We might not be alone, and we could be living in the shadow of a forgotten colossal construction. Join us as we peel back the layers of conventional astronomy, examining the peculiar seismic echoes that made the moon ring like a bell, its enigmatic and possibly low density, and the impossible orbital mechanics that form the bedrock of the hollow moon theory. Like and subscribe if you're ready to explore the universe's most guarded secrets, and prepare to look at our moon forever with new eyes. Let's begin. High above us, a pearl in the velvet black, hangs the moon. For as long as humanity has gazed skyward, it has been our constant companion, a celestial body so integrated into our rhythm of life, our art, and our very language, that we seldom pause to consider its true nature. We accept it as a given, a natural consequence of planetary formation, a familiar sphere of rock and dust that simply is. But this familiar presence, this silent sentinel, harbours secrets that defy easy explanation, anomalies so profound they challenge the very narrative of its cosmic birth. Our moon is not merely Earth's satellite, it is a titan among moons, disproportionately massive relative to its parent planet. To illustrate, consider Mars, a world roughly half the size of Earth, orbited by two tiny potato-shaped asteroids, Phobos and Deimos. Jupiter, the colossal king of our solar system, boasts a retinue of dozens of moons, its largest, Ganymede, a world in its own right, yet still a fraction of Jupiter's immense girth. Our moon, however, is a staggering 1/4 the diameter of Earth, making the Earth-Moon system almost a binary planet, a dual dance unique among the inner solar system's planetary pairings. This sheer scale isn't just an aesthetic curiosity. It's a profound gravitational anchor that has shaped Earth's geological and biological destiny in ways we're only beginning to fully appreciate. This extraordinary size, combined with its remarkably stable and almost perfectly circular orbit, presents the first significant challenge to conventional models of lunar formation. Mainstream science widely accepts the giant impact hypothesis, suggesting a Mars-sized protoplanet, Theia, collided with early Earth, ejecting debris that coalesced into the moon. This theory elegantly explains many aspects of the moon's composition and the Earth's tilted axis. Yet, it struggles to account for the moon's suspiciously low density, a characteristic that hints at something far less solid than a typical planetary body. If it formed from Earth's mantle, it should be denser. Instead, it seems lighter than it should be. Beyond its size and mass, the moon's orbital mechanics exhibit a peculiar precision that borders on the uncanny. It is tidally locked with Earth, meaning it always presents the same face to us, a common enough phenomenon for many moons. However, the exactitude of this synchronicity, coupled with its nearly circular path around our planet, raises questions about its natural evolution. The lunar orbit is exquisitely fine-tuned, a cosmic ballet that maintains its equilibrium despite eons of gravitational tugs and pulls from other celestial bodies. Such stability, sustained over billions of years, seems less like chance and more like a carefully maintained design, an intricate clockwork defying the chaotic forces of cosmic mechanics. Furthermore, The Moon acts as a celestial gyroscope, stabilizing Earth's axial tilt to a remarkable degree. Without its massive gravitational influence, Earth's tilt would wobble far more dramatically, leading to catastrophic and unpredictable climate shifts that would likely have prevented the long-term stability necessary for complex life to evolve and thrive. In essence, the Moon doesn't just orbit us, it nurtures us, regulating our seasons, generating the tides that may have been crucial for life's emergence from primordial oceans, and ensuring a predictable environment that allowed evolution to take its slow, deliberate course. This too-perfect relationship elevates the Moon from a mere space rock to an indispensable architect of Earth's habitability, blurring the line between a natural accident and an engineered necessity. The scientific community, while acknowledging these peculiarities, typically attributes them to complex interactions of gravitational forces and the immense timescales involved in celestial mechanics. They propose intricate models and simulations that attempt to reconcile these anomalies within the framework of natural formation. However, for a growing number of independent researchers and theorists, these explanations feel like intellectual gymnastics, bending known physics to fit a preconceived natural origin, rather than genuinely addressing the profound statistical improbabilities. They argue that the cumulative effect of these oddities, when viewed without bias, points towards a far more radical conclusion. As we delve deeper into the specific evidence, we will uncover why these general characteristics of our Moon lead to an almost inescapable question. Is it truly a natural celestial body, born of cosmic happenstance, or is it something else entirely? Could the very anomalies that perplex astronomers be the most compelling clues, irrefutable exhibits of a monumental secret hiding in plain sight? The Moon hangs above us, familiar yet profoundly alien, a silent testament to a hidden truth that official science, perhaps by its very nature, is compelled to ignore. Its unique position, its strange behaviour, and its life-giving influence on Earth invite us to reconsider everything we thought we knew about our closest neighbour. What if its familiarity is precisely its most effective camouflage? End of hook section. Our journey into the Moon's enigmatic nature began in earnest, not with distant observations, but with direct physical interaction. The Apollo missions, humanity's triumphant leap to another world, brought back not just lunar samples and iconic images, but also a trove of perplexing data, perhaps the most unsettling of which came from the very ground beneath the astronauts' feet. It was here, in the cold, silent vacuum, that the Moon offered its most startling secret. It resonated, not like a solid celestial body, but like a colossal, metallic gong. The stage for this extraordinary discovery was set during Apollo 12 in November 1969. After successfully landing and deploying a passive seismic experiment package, a sophisticated seismometer designed to detect moonquakes and meteorite impacts, the lunar module's ascent stage, the SVB, was intentionally deorbited and crashed back onto the lunar surface. The impact site was approximately 74 kilometers from the deployed seismometer. Scientists on Earth, monitoring the data streams, expected a seismic signature typical of a solid rocky body. A rapid, sharp shock wave followed by a quick decay, much like dropping a stone into a puddle. What they received instead was utterly unprecedented. The Moon began to reverberate not for minutes, but for an astonishing hour. Seismologists at NASA's Manned Spacecraft Center were reportedly flabbergasted. Maurice Ewing, a pioneering geophysicist and one of the lead investigators, famously declared, "The Moon rang like a bell." The tremors didn't dissipate quickly, as they would on a geologically active body like Earth, with its liquid core and layers of dense rock designed to dampen seismic energy. Instead, the vibrations seemed to travel deep beneath the surface, echoing and oscillating with a persistent, almost musical quality, as if trapped within a massive hollow sphere. This wasn't an isolated incident. The mystery only deepened with Apollo 13, ironically a mission fraught with peril, yet one that provided even more compelling seismic evidence. When the mission's jettisoned SVB third stage, weighing nearly 15 tons, was deliberately crashed onto the lunar surface on April 14, 1970, the impact energy was significantly greater. The subsequent seismic event, recorded by the Apollo 12 seismometer, was even more dramatic. The Moon vibrated for an incredible 4 hours, with the initial shockwave intensifying for a period before slowly fading. It was described as having a distinctly synthetic resonance, unlike any natural phenomenon observed on Earth or theorized for other planetary bodies. Think for a moment about how seismic waves behave on our own planet. When an earthquake strikes, it generates distinct P waves, compressional, faster, and S waves, shear, slower, that travel through Earth's various layers. These waves are absorbed, reflected, and refracted by the dense mantle and liquid outer core, attenuating relatively quickly. We can map Earth's interior, from its molten core to its tectonic plates, precisely because these waves interact with solid and liquid matter in predictable ways. The Moon's response, however, defied these known principles. The waves propagated for extraordinary durations, losing very little energy and exhibiting a peculiar dispersion pattern that suggested a radically different internal structure. Further Apollo missions, including 14, 15, and 16, continued to deploy seismic stations, creating a network that covered a significant portion of the lunar near side. Each controlled impact, whether from spent rocket stages or lunar modules, consistently generated these long-duration vibrations. The data consistently painted a picture of a lunar interior that was remarkably uniform, unusually rigid, and strikingly less dense than expected for a body of its size. The notion of a completely solid, homogeneous rock ball was increasingly difficult to reconcile with the observations. The waves seemed to bounce around within the Moon, reflecting off an internal boundary that attenuated energy far less efficiently than solid rock. Mainstream scientific explanations for this ringing effect often point to the Moon's extremely dry, fractured regolith, a porous surface layer of dust and broken rock, and the absence of water to dampen vibrations. They suggest that in such a vacuum, seismic energy would simply travel further and persist longer without the damping effects of Earth's fluid-filled crust and mantle. However, even with these factors accounted for, the sheer duration and peculiar resonance still stretch the bounds of conventional geophysical models. The Moon's seismic behavior does not merely differ subtly from Earth's. It appears to operate under a fundamentally different set of rules for internal structure and wave propagation. For proponents of the hollow moon theory, this seismic data is not just an anomaly to be explained away by surface conditions, it is a smoking gun. If a planetary body rings like a bell, it strongly implies a hollow, or at least a partially hollow interior, perhaps a dense outer shell surrounding a less dense or even empty core. Imagine striking a bowling ball versus striking an empty metal sphere. The difference in resonance is palpable. The Moon's persistent reverberation, its ability to sustain vibrations for hours, suggests a construction that maximizes resonance, a structure designed to contain rather than absorb energy, a colossal sphere with an interior that is not naturally solid. This interpretation directly challenges the foundational assumption of all celestial bodies being solid or molten spheres. It pushes us to consider what kind of force, natural or otherwise, could create a celestial object of such immense size with an internal structure so antithetical to our understanding of planetary physics. The seismic echoes from Apollo are not just data points, they are ghostly whispers from a construction that defies our expectations, a fundamental characteristic that official science, while meticulously recording, seems hesitant to fully embrace in its most radical implications. They are clues, patiently waiting for us to connect the dots and question the very nature of our cosmic neighbour. The strange symphony of the Moon's seismic echoes, its persistent bell-like reverberations, was but one piece of a cosmic puzzle. Another, equally profound, lies hidden within the very substance of our celestial neighbour, its unnervingly low density. This characteristic, calculated with meticulous precision, presents a core paradox that strikes at the heart of conventional planetary formation theories and offers a potent argument for the Moon's potentially artificial nature. Planetary scientists determine the density of celestial bodies through a combination of their mass and volume. The Moon's mass has been accurately measured through tracking the orbital perturbations of lunar probes and the gravitational effects on spacecraft. While its volume is derived from its well-known diameter, the resulting average density of the Moon clocks in at approximately 334 grams per cubic centimetre. To fully grasp the significance of this figure, it demands context. Compare it to Earth's average density, a robust 5.51 grams per cubic centimetre. Our home planet boasts a dense iron-nickel core, which accounts for much of its overall mass and gravitational pull. Even the inner rocky planets like Mercury and Venus exhibit significantly higher densities than the Moon, consistent with their formation from heavier elements closer to the Sun. So, what does this mean for the Moon? Its lower density suggests a fundamental difference in its internal composition compared to other rocky bodies in the inner solar system. Specifically, it implies a much smaller, or perhaps even absent, iron-nickel core. This is where the core paradox begins to unravel the established narrative. If the Moon truly formed from the debris ejected during the colossal impact hypothesized by the giant impact theory, a collision between early Earth and a Mars-sized protoplanet, one would expect its bulk composition to be remarkably similar to Earth's mantle, the primary source of the ejected material. However, Earth's mantle, while less dense than its core, is still considerably denser than the Moon's average, presenting a direct contradiction. This discrepancy forces mainstream science into a delicate dance of theoretical adjustments. Some models propose that the impacting body, Theia, was itself unusually low in heavy elements, or that the collision stripped away disproportionately more of Earth's lighter, outer crust, leaving the heavier core materials behind on Earth. Other hypotheses suggest that during the accretion process, lighter silicates preferentially gathered to form the Moon, while heavier elements were somehow excluded. These explanations, while attempting to preserve the natural formation paradigm, often require a series of highly specific and perhaps statistically improbable conditions to align perfectly, stretching the limits of scientific parsimony. For those who dare to consider the radical, the Moon's low density, when coupled with its seismic behavior, paints a far more coherent and provocative picture. If the Moon rings like a bell, and if its overall mass is too light for its immense volume and seemingly solid appearance, then the logical conclusion points towards an interior that is largely hollow, or at least significantly less dense than its exterior shell. Imagine a colossal sphere, perhaps kilometers thick in its outer layers of rock and regolith, but with a vast, empty, or near-empty void beneath. This would explain both the persistent reverberations of seismic waves, which would travel across and reflect within a hollow chamber for extended periods, and the overall low average density. It's the difference between a solid cannonball and a carefully constructed hollow sphere of the same external dimensions. The implications of such a structure are staggering. A hollow moon, particularly one of its size, cannot be a naturally formed object by any known astrophysical process. Planets and moons form through accretion, where gravity slowly pulls together dust and rock, gradually compressing the material into a dense, solid sphere. This process inherently leads to a denser core composed of heavier elements. The idea of a celestial body forming naturally with a massive empty interior, a void within its very heart, challenges fundamental laws of planetary geology and gravitational dynamics. It would suggest an intelligence, an act of engineering on a scale that dwarfs human ambition, purposefully crafting a cosmic vessel rather than allowing nature's forces to take their course. This hollow world concept isn't merely a fringe speculation. It resonates with various historical observations and even some scientific musings. Ancient Greek philosophers, long before the age of space travel, pondered a hollow Earth. While their theories were rooted in myth, the concept of a designed or artificial celestial body has intermittently surfaced in scientific thought, often quickly dismissed. Yet, the Moon's density anomaly, consistently measured and verified, refuses to vanish. It remains an uncomfortable truth, an unyielding data point that demands a more satisfying answer than the convoluted explanations currently offered by conventional science. The true paradox lies not just in the Moon's density, but in the scientific community's reluctance to fully explore its most direct implications. To acknowledge a hollow interior is to open the door to a cascade of further questions. Who built it? Why? And for what purpose? It forces a confrontation with the uncomfortable possibility that our understanding of the cosmos and our place within it might be far more limited than we assume. The Moon, in its unnatural lightness, therefore stands as a silent monument, a colossal enigma whose very mass, or lack thereof, whispers of an origin far beyond the conventional and into the realm of the truly extraordinary. From the Moon's internal structure, a paradox of lightness and resonance, we now turn our gaze to its external behavior, a a cosmic ballet performed with such breathtaking precision that it inspires both awe and profound skepticism. We speak, of course, of the total solar eclipse, a celestial event so geometrically perfect it forces us to confront the deepest questions about the moon's very existence. Imagine standing on Earth, witnessing a total solar eclipse. For a few precious minutes, the moon, a mere speck in the vastness of space, aligns itself so flawlessly with the distant colossal sun that it completely obscures our star's fiery disk. The blazing corona, usually hidden by the sun's blinding light, erupts into view, a crown of ethereal plasma against the sudden twilight. Birds fall silent, temperatures drop, and a primal sense of wonder grips those who behold it. This isn't just a shadow passing, it's a cosmic vanishing act, orchestrated with an exactitude that borders on the miraculous. The reason for this stunning spectacle lies in an extraordinary coincidence. The moon is approximately 400 times smaller than the sun in actual diameter. Yet, by an astonishing stroke of cosmic fortune, it is also approximately 400 times closer to Earth. This creates a perfect angular diameter match. From our perspective on Earth, the moon and the sun appear almost precisely the same size in the sky. It is this improbable ratio that allows the moon to cover the sun's disk with such surgical accuracy, neither too small to reveal a sliver of sunlight, nor too large to completely blot out the corona. It's like having two coins, one the size of a dinner plate and the other the size of a dime, and finding that when you hold them at specific distances they perfectly overlap. The sheer statistical improbability of this alignment, sustained over eons, is where the scientific narrative begins to fray for many. Our solar system is a realm of immense diversity and occasional chaos. Planets orbit on ellipse, moons are often captured asteroids, and the forces of gravity are constantly nudging, pulling, and altering celestial trajectories. For our moon, a body of its unique size and density, to settle into an orbit that maintains this precise angular relationship with both Earth and the Sun, and to sustain it across billions of years of solar system evolution, appears less like random chance and more like a carefully calibrated setup. It is a cosmic bullseye, hit with every single total eclipse, a testament to an arrangement that feels too convenient to be truly accidental. Consider the other moons in our solar system. Jupiter's Ganymede or Callisto, Saturn's Titan. These are massive, complex worlds. Yet, none of them provide such a geometrically perfect spectacle for their respective planets. Their eclipses are either annular, the moon appears too small, leaving a ring of sunlight, or partial. Earth's moon is the only one that provides total solar eclipses with this level of precision, transforming a commonplace astronomical event into a phenomenon of profound elegance and mystery. This singular characteristic elevates our moon to an almost sentinel status, an intentional design element rather than a product of mere accretion. Mainstream astronomy, while acknowledging the coincidence, generally attributes it to the vastness of the universe and the immense numbers involved. In a cosmos filled with countless stars and planets, surely such an alignment is bound to happen somewhere, eventually. They point to the moon's slow recession from Earth, a phenomenon where our moon is gradually drifting farther away, meaning that in the distant past it would have appeared larger, and in the far future it will appear smaller, eventually rendering total solar eclipses impossible. Therefore, we are simply living in a privileged epoch of totality, a brief window of time where this perfect alignment occurs. However, this explanation often fails to satisfy those who scrutinize the irrefutable clues. The argument of a privileged epoch feels less like a solution and more like a deferral of the question. It doesn't explain how such a massive low-density object achieved this specific orbit in the first place, or why its recession rate is precisely what it is. For proponents of the hollow moon theory, the elegant mechanics of a total solar eclipse are not a random lottery win but a fundamental signature. It implies purpose, a design intent that positions the moon not just as an orbiting body, but as a deliberate instrument, perhaps for observing Earth, for regulating its environment, or even for concealing something from external view. This perfect fit hints at an intelligence that understood orbital mechanics, mass distribution, and optical geometry to an astonishing degree. It's the ultimate example of a cosmic watchmaker, crafting a mechanism with such exacting tolerances that it performs a precise function for billions of years. Could this perfect alignment serve as a celestial marker, a signal for something or someone, or a sophisticated camouflage? If the moon is indeed an artificial construct, then its precise position for solar eclipses could be one of its primary design parameters, a function built into its very orbital blueprint. The eclipse enigma therefore forces us to look beyond the natural and contemplate the engineered. It transforms the serene beauty of a total solar eclipse into a profound question mark hanging in the sky. The moon's seismic behaviour suggests an internal void. Its density points to an impossibly light composition, and its orbit now reveals a geometric perfection that feels anything but accidental. Together, these clues weave a narrative that challenges scientific orthodoxy, pushing us to consider that our silent sentinel is not merely a rock in the sky, but a monumental artifact, a crafted sphere whose very presence is a carefully orchestrated secret, hidden in plain sight by the very spectacle it creates. Having explored the moon's unsettling internal acoustics, its perplexing density, and its uncanny orbital precision, it becomes essential to understand how these anomalies challenge the prevailing scientific narratives regarding its origin. Mainstream science, while acknowledging the moon's unique characteristics, strives to fit them within a natural formation framework. Yet, the very diversity and shortcomings of these official explanations often highlight the profound mysteries that remain. For decades, the leading scientific hypothesis for the moon's formation has been the giant impact hypothesis, sometimes called the Theia impact. This theory posits that early in Earth's history, roughly 4.5 billion years ago, a Mars-sized protoplanet named Theia collided with our nascent Earth. The immense energy of this impact vaporized and ejected vast quantities of material from both bodies into orbit, which then coalesced over time under gravitational forces to form the moon. This model gained significant traction because it successfully explains several key observations: the moon's overall composition, which is similar to Earth's mantle, the relatively small iron core of the moon, and the Earth's present-day axial tilt and rapid rotation. However, even the giant impact hypothesis, elegant as it is, faces considerable hurdles when confronted with the precision and peculiarity of the moon's characteristics. For instance, detailed analysis of lunar rock samples brought back by the Apollo missions revealed isotopic similarities between Earth and moon rocks that are too close. If Theia was a truly distinct body, even if it contributed most of the moon's material, one would expect a more distinct isotopic fingerprint from the impactor. Instead, the oxygen isotopic ratios, for example, are almost identical to Earth's, suggesting the moon is predominantly made of Earth material, or that Theia itself was isotopically identical to Earth, which is another improbable coincidence. This isotopic crisis necessitates further refinement of the giant impact model, often requiring highly energetic, high angular momentum impacts that are difficult to model consistently. Another significant challenge for the giant impact hypothesis, and indeed for any natural formation theory, is the moon's notoriously low density, as discussed. If the moon primarily formed from Earth's mantle, and given its enormous size, it should be significantly denser than it is. While some models propose that the impact preferentially ejected lighter materials, or that the moon later differentiated in an unusual way, these explanations often feel like post hoc adjustments designed to rescue the theory from inconvenient facts. The seismic data, indicating a potentially hollow or very low density interior, further strains the credibility of models that assume a conventional solid internal structure for a body of its scale. Beyond the giant impact, other historical theories of lunar origin have largely been discarded due to insurmountable scientific objections. The fission theory, popular in the late 19th and early 20th centuries, suggested the moon spun off from a rapidly rotating early Earth, perhaps from the Pacific Ocean basin. However, this theory requires an impossibly high initial spin rate for Earth and fails to account for the moon's present orbital angular momentum. Then there was the capture theory, proposing the moon formed elsewhere in the solar system and was later gravitationally captured by Earth. This would explain compositional differences, but orbital dynamics make such a capture highly improbable, typically resulting in a highly elliptical orbit, not the moon's nearly circular one. Furthermore, a massive body like the Moon would likely have either crashed into Earth or been flung out of the solar system during a close encounter, not settled into such a stable path. Finally, the co-accretion theory suggested Earth and Moon formed together from the same primordial disk of material, akin to a binary planet system. While this could explain some compositional similarities, it struggles to account for the Moon's lower density and the Earth-Moon system's high angular momentum. None of these classical theories adequately explain the full suite of lunar anomalies: the precise solar eclipse alignment, the bell-like ringing, the low density, and the isotopic similarities, without introducing additional, often complex and improbable, secondary assumptions. This intellectual landscape, marked by a multitude of competing and imperfect explanations, is precisely where the hollow moon hypothesis finds its most fertile ground. It offers a single, radical explanation that, for its proponents, elegantly resolves these disparate anomalies. If the Moon is an artificial construct, a colossal shell, then its low density, its seismic resonance, and its uncanny orbital precision cease to be improbable coincidences. Instead, they become deliberate design features. The isotopic similarities might be explained if some Earth materials were incorporated into its construction, or if the builders sourced materials from multiple locations. The precise orbit and size for eclipses could be a functional aspect, a monitoring station, or a deliberate form of camouflage. The scientific establishment, however, largely regards the artificial moon hypothesis as pseudoscience, or at best, an extraordinary claim requiring extraordinary proof. They correctly point out that while anomalies exist, they do not automatically necessitate an extraterrestrial or artificial origin. They argue that scientific progress lies in refining existing natural models, not in invoking unknown super technologies. Yet, the persistent discomfort generated by the Moon's eccentricities remains. The reluctance to entertain truly radical alternatives, even when conventional explanations become increasingly convoluted, highlights a systemic blind spot, a preference for the familiar even when the evidence whispers of the profound. Ultimately, the debate over lunar origins is more than just an academic exercise. It forces us to confront the limits of our understanding and the boundaries of our imagination. Is the Moon a product of chaotic cosmic forces, a series of improbable coincidences that just happen to work out perfectly for life on Earth? Or is it a testament to an ancient, powerful intelligence that sculpted a world, parked it in orbit, and left us to ponder its silent, watchful presence? The competing theories of lunar origins, particularly their struggles to fully explain the data, inadvertently open the door wider for the most audacious possibility that Earth's closest companion is not a creation of nature, but a marvel of engineering. Beyond its internal composition and its mesmerizing eclipse-making ability, the Moon's very motion through space around Earth presents another layer of profound anomaly. In a cosmos governed by chaotic variables, where gravitational dance often leads to elliptical paths and eventual escape or collision, the Moon's orbital precision stands out as an almost impossible feat of celestial mechanics, prompting questions about an origin far more deliberate than mere cosmic chance. To fully appreciate this orbital enigma, we must first understand the typical behavior of natural satellites. Most moons, especially those not formed in situ from the accretion disk of their parent planet, tend to have elliptical orbits. Consider the dozens of irregular moons orbiting Jupiter and Saturn. Many are captured asteroids, tugged into highly eccentric paths that are unstable over geological timescales, often gradually decaying or eventually being ejected. Even our own solar system's planets orbit the Sun on elliptical paths, not perfect circles, a consequence of their formation and the gravitational interactions over billions of years. The Moon, by contrast, maintains an orbit around Earth that is extraordinarily close to a perfect circle. While not a mathematical ideal, its eccentricity is remarkably low, averaging around 0.05. This means its distance from Earth varies by only about 6% throughout its cycle. Such a stable, near-circular path, particularly for a body as massive as the Moon, is highly unusual. It suggests a history that avoided the gravitational slingshots and chaotic perturbations that typically sculpt more eccentric orbits. If the Moon were a captured body, it's statistically improbable for it to have settled into such a harmonious, long-lived dance. If it coalesced from a debris disk, its density and compositional issues remain. What makes this orbital stability even more perplexing is the concept of orbital decay and gravitational perturbations. Over billions of years, the gravitational influence of the Sun, Jupiter, and other celestial bodies should, theoretically, have exerted a more significant disruptive effect on the Moon's trajectory. Yet, our Moon has maintained its delicate balance, resisting the forces that might have sent it spiralling inwards towards Earth or flinging it outwards into the depths of the solar system. Its orbital plane, though slightly inclined to Earth's equator, remains remarkably consistent, a testament to an enduring equilibrium. This stability is not merely a passive observation, it has profound implications for Earth. As discussed, the Moon's massive presence acts as a celestial anchor, stabilizing Earth's axial tilt. Without the Moon's precise gravitational pull, Earth's rotational axis would wobble far more dramatically, potentially shifting from 0 to 85 degrees over millions of years. Such a drastic wobble would lead to catastrophic and unpredictable climate changes, rendering long-term planetary habitability highly unlikely. The Moon's orbital precision, therefore, is not just a geological curiosity, it is a fundamental prerequisite for the sustained evolution of complex life on Earth, a cosmic thermostat maintaining our planet's delicate environmental balance. Conventional astronomy explains the Moon's near-circular orbit as a product of tidal forces, a gravitational feedback loop between Earth and Moon that gradually circularizes orbits over immense timescales. However, this process, while real, typically works best on smaller moons, or those that formed much closer to their parent planet. For a moon as massive and distant as ours, the degree of circularity achieved and maintained for billions of years still pushes the boundaries of statistical expectation, especially when weighed against the backdrop of its other anomalous properties. The tidal circularization argument, while valid in principle, often feels stretched to accommodate the Moon's unique case. For proponents of the hollow moon hypothesis, this orbital perfection is yet another powerful indicator of intelligent design. If the Moon were an artificial construct, a colossal spacecraft or a manufactured satellite, then its precise, stable, and near-circular orbit would be a fundamental engineering requirement. It would be placed intentionally in a perfectly calculated trajectory to fulfill specific functions, whether for observation, environmental regulation, or as a hidden base. Its stability would be a testament to the advanced capabilities of its creators, who could not only construct a celestial body but also position it with unparalleled accuracy for eons. This perspective shifts the Moon from a passive consequence of cosmic evolution to an active participant, a deliberate instrument in a much grander scheme. The near-perfect circularity, the precise distance, and the long-term stability all align with the idea of an object placed with intent, rather than simply having found its way through the vagaries of gravitational physics. The impossible orbit becomes less about natural probability and more about engineering exactitude, transforming a celestial body into a piece of cosmic architecture. The scientific community, while documenting the Moon's orbital characteristics with great detail, tends to interpret them through the lens of incremental evolutionary processes. They look for the gradual nudges and adjustments of gravity over billions of years that could lead to the observed stability. However, the cumulative weight of the Moon's anomalies, the seismic resonance, the low density, the perfect eclipse alignment, and now its unparalleled orbital precision, suggests a pattern that transcends mere chance. These aren't just isolated quirks, they are interconnected clues, each one pointing towards a conclusion that challenges our most fundamental assumptions about the natural universe. The Moon, in its silent, graceful dance around Earth, continues to be a familiar mystery, its very presence a paradox that official science, in its adherence to conventional models, may be inadvertently ignoring. Our investigation into the Moon's perplexing nature has journeyed through its internal reverberations, its astonishingly low density, and its uncanny orbital precision. Now, we turn our attention to the lunar surface itself, a landscape scarred by billions of years of cosmic impacts, yet still bearing strange signatures that some argue are not purely natural. The craters and the very regolith, the dusty broken rock covering the Moon, may hold further clues, quietly challenging our understanding of our companion's true composition and origin. The Moon's surface is a testament to cosmic violence, pockmarked by countless impact craters. These ranged from microscopic pits to vast basins hundreds of kilometers across, remnants of an early solar system bombardment that shaped every rocky body. Scientists use the size and distribution of these craters to estimate the age of lunar surfaces, with heavily cratered regions indicating greater antiquity. However, closer examination of some of these impact features reveals anomalies that defy simple geological explanation, hinting at an underlying structure far more resilient than expected. A particularly striking observation from the Apollo missions was the shallow depth of many large lunar craters. For impacts of such immense energy, especially those creating basins hundreds of kilometers in diameter, conventional models predict a much deeper penetration into the lunar crust. Instead, many of the Moon's largest craters, like the Imbrium Basin, appear remarkably shallow relative to their width. It's as if the impactors hit something unyielding just beneath the surface, preventing deeper excavation. This phenomenon has led to what some have termed the bedrock problem, where the lunar crust seems abnormally tough or supported. Consider an analogy: dropping a heavy steel ball onto a thick layer of sand versus dropping it onto a thin layer of sand covering solid steel. In the latter case, the impact crater would be broad but shallow, the underlying steel resisting deep penetration. For the Moon, this unyielding bedrock effect is observed repeatedly. If the Moon possesses a dense solid core, one would expect impacts to penetrate more deeply, especially given the Moon's relatively low average density. The shallow craters therefore lend further credence to the hollow Moon hypothesis, suggesting a hard, resistant outer shell that can withstand massive impacts without catastrophic internal collapse. Such a shell would need to be engineered to a degree far beyond natural geological processes, perhaps constructed from super-strong materials or a sophisticated internal bracing system. Furthermore, the composition of the lunar regolith itself offers subtle hints. Analysis of lunar soil samples brought back by Apollo revealed traces of unusual, often processed metallic particles. While most of the regolith is pulverized rock, some samples contained microscopic spheres of pure iron, titanium and other metals in forms not typically found in naturally occurring lunar rock. While these could be explained by meteoritic impacts or unusual volcanic activity, their presence in such high purity raises questions. Could these be remnants of industrial processes, accidental filings, or even deliberate additives from the Moon's construction, slowly mixed into the surface by eons of micrometeorite bombardment? The distribution of mass concentrations, or mascons, beneath the lunar surface also presents a puzzle. These are regions of unusually high gravity, typically found beneath the large circular maria, the dark plains we see from Earth, which are actually ancient lava flows that filled impact basins. While mascons are generally attributed to the dense basaltic lava that flooded these basins, the precise, circular distribution of many of them and their unexpected gravitational pull has led to speculation. Could these mascons be more than just solidified lava? Could they represent massive structural components, internal reinforcing rings, or even buried machinery within a hollow sphere, strategically placed to maintain structural integrity and gravitational balance? The sheer size and uniformity of these mascon features, perfectly concentric with the vast circular basins, feel less like random geological anomalies and more like embedded components. Official science, of course, explains these phenomena through various geological mechanisms. The shallow craters are attributed to differences in lunar crustal strength and the mechanics of hypervelocity impacts in a vacuum. The metallic particles are explained as the result of meteoritic infall or specific geochemical processes. Mascons are understood as localized concentrations of denser material within the Moon's mantle or crust, often associated with impact basin fill. Each explanation is plausible in isolation, but when viewed collectively against the backdrop of the Moon's other profound anomalies, its bell-like ringing, its low overall density, and its impossibly precise orbit, these natural explanations begin to feel like a patchwork of convenient assumptions stitched together to avoid a more radical, unsettling truth. The strange surface signatures of the Moon, therefore, become critical pieces of indirect evidence. They suggest an underlying resilience and a structural integrity that goes beyond what we expect from a naturally formed celestial body. The shallow craters imply a hard shell. The unusual metallic traces hint at industrial presence. The mascons suggest internal reinforcement. Each hint, each anomaly, when added to the growing dossier of the Moon's peculiarities, pushes us further towards the conclusion that our silent sentinel is anything but natural. It transforms the serene, cratered face of the Moon into a monumental blueprint, a visible yet cryptic map of a colossal construction whose secrets are etched into its very surface, patiently awaiting our recognition. Having scrutinized the Moon's seismic whispers, its anomalous density, and the cryptic clues etched onto its cratered face, we now delve into another deeply unsettling aspect, its chemical composition. When scientists analysed the lunar samples brought back by the Apollo missions, they encountered an elemental profile that, in several critical ways, defied the expectations of natural planetary formation, and instead hinted at an origin that was either extraordinarily unique or, more provocatively, artificial. The Earth and Moon share remarkable similarities in their oxygen isotope ratios, a key piece of evidence often cited in support of the giant impact hypothesis, which suggests a common origin for their material. However, this similarity paradoxically deepens the mystery when considering other crucial elements. While oxygen isotopes align, many volatile elements, those with lower boiling points, are significantly depleted on the Moon compared to Earth. This includes elements like nitrogen, hydrogen, and carbon, which are abundant on Earth and would theoretically have been present in the debris disk from which the Moon supposedly formed. Their scarcity on the Moon suggests either extreme processing or a formation under conditions radically different from Earth's. Even more perplexing is the apparent disproportion in heavier refractory elements, those with high boiling points. For instance, the Moon contains unexpectedly high concentrations of refractory elements such as titanium, uranium, and thorium in its outer layers, particularly in the lunar maria. While these elements are present in Earth's crust, their enrichment on the Moon, especially in its surface regions, is difficult to explain by standard accretion models. If the Moon formed from a debris disk, one would expect a more even distribution or a higher concentration of these heavier elements deep within its core due to gravitational differentiation. Instead, we see them concentrated closer to the surface, almost as if they were deliberately placed or are components of an outer shell. This peculiar distribution of elements leads to significant challenges for established lunar formation theories. The giant impact hypothesis, for example, struggles to coherently explain both the isotopic similarities and the volatile depletion and the refractory enrichment in a single, consistent model. If the Moon formed from a superheated impact plume, some models suggest volatiles would boil off, but the subsequent enrichment of refractories in specific regions remains an awkward fit. It's a bit like trying to bake a cake with a recipe that calls for precisely measured ingredients, but the final product always turns out with half the sugar missing and twice the salt on top, concentrated in odd patches. For proponents of the hollow moon theory, these chemical anomalies are not mere geological quirks to be explained away. They are further irrefutable clues pointing towards an engineered construct. If the Moon were an artificial satellite, then its elemental composition could reflect the deliberate selection and placement of materials by its builders. The volatile depletion might be explained by a construction process in the vacuum of space, or the use of pre-processed materials. The enrichment of heavy, durable elements like titanium in the outer layers could be a signature of a robust protective hull, an armor plating designed to withstand cosmic impacts and radiation over eons. Imagine a colossal spacecraft or a manufactured habitat. Its outer shell would logically be constructed from strong, stable materials, possibly enriched with heavy elements for durability and radiation shielding. Its interior, if hollow, would not require the dense, heavy core expected of a naturally formed body. The chemical signatures we observe, the volatile depletion, and the surface enrichment of refractories would be entirely consistent with such a design. It shifts the perspective from random geological processes to intentional material science, from chaos to controlled construction. Moreover, the presence of certain isotopes, specifically the unusually high ratio of radioactive potassium-40 to uranium-238 and thorium-232, also known as the CREEP anomaly, is another fascinating puzzle. CREEP, an acronym for potassium, rare earth elements, and phosphorus, is a geochemical component found in many lunar rocks. Its high concentration and widespread distribution on the Moon suggest a unique and widespread magmatic process that is not easily replicated in terrestrial models. Some theories link it to the last stages of lunar magma ocean solidification, but its specific abundance and distribution continue to be debated. For alternative theories, this unique geochemical signature could be interpreted as a byproduct of a specific industrial or technological process, rather than a purely natural one. The sheer difficulty in reconciling these diverse compositional characteristics within a single, elegant natural formation model points to a fundamental gap in our understanding. Official science continues to seek elaborate geological scenarios involving multiple impact events, complex differentiation processes, and specific thermal histories to explain these observations. Yet, the persistent need for these increasingly intricate explanations only highlights the struggle. It forces us to ask, at what point do a collection of anomalies cease to be exceptions and begin to define a new, unacknowledged rule? The Moon's missing elements and its strangely distributed refractories therefore stand as chemical fingerprints, not necessarily of natural geological evolution, but potentially of a sophisticated extraterrestrial manufacturing process. They suggest that the Moon is not merely a product of chance, but a carefully assembled structure, its very chemistry betraying the purposeful selection and arrangement of materials. The silence of the void may conceal a grander truth, and the composition of the lunar soil could be one of its most compelling, yet overlooked, confessions. We've meticulously catalogued the Moon's profound anomalies, its unsettling seismic resonance, its inexplicably low density, its geometrically perfect alignment for solar eclipses, its uncannily stable orbit, the peculiar shallow depth of its craters, and its baffling chemical composition. Each piece of evidence, taken individually, presents a significant challenge to conventional lunar formation theories. But when these irrefutable clues are synthesized, they coalesce into a single, audacious, and deeply unsettling proposition. The Moon is not a natural celestial body, but an artificial construct, a monumental feat of extraterrestrial engineering. The implications of an engineered Moon are nothing short of revolutionary, shattering our anthropocentric view of the cosmos and forcing a radical re-evaluation of humanity's place within it. If our closest celestial neighbour is, in fact, an alien artifact, then we are not alone, and perhaps never have been. This realization would rewrite history, not just of our planet but of life itself. It would transform the silent, indifferent void into a stage for ancient, unimaginable powers, placing Earth squarely within a narrative of cosmic design and surveillance. Consider the sheer scale of such an undertaking. To construct an object the size of the Moon, with a diameter of over 3,474 kilometers, would require resources, technology, and engineering capabilities that dwarf any human endeavor. We speak of building a Dyson sphere as the ultimate achievement of a Type II civilization on the Kardashev scale. An artificial moon, precisely positioned and internally structured, would represent an equivalent, if not greater, mastery over matter and energy. This isn't just about moving mountains, it's about building them to exact specifications from the ground up, or rather, from the vacuum in. What would be the purpose of such a colossal construct? The hollow moon theory suggests several possibilities, each more speculative but equally thought-provoking. It could be an ancient derelict mothership, a gargantuan vessel parked in orbit after a journey of unfathomable duration. Its hollow interior could house vast habitats, advanced machinery, or a dying civilization preserving itself. The outer shell, constructed with durable, heavy elements, would serve as protection against the harsh cosmic environment, explaining the shallow craters and the high concentration of refractories near the surface. Alternatively, the Moon could be a monitoring station, a strategically placed observation post designed to watch over Earth's nascent life. Its perfect eclipse-making ability might not be accidental. It could be a deliberate feature, perhaps a unique optical or energy-harvesting mechanism, or even a form of subtle communication. The precise, stable orbit would ensure long-term uninterrupted surveillance, a silent sentinel witnessing the slow, unpredictable unfolding of biological and technological evolution on our world. From this perspective, humanity's entire history has been unfolding beneath the gaze of an unseen colossal eye. The concept of paleo-contact, the idea that advanced extraterrestrial civilizations visited Earth in the distant past, finds potent reinforcement in the artificial moon hypothesis. If the moon was engineered, it implies a presence, a visitation, that predates human civilization by billions of years. This would challenge archaeological and anthropological narratives, suggesting that our most ancient myths and enigmatic structures might be echoes of a forgotten encounter, distorted memories of beings who shaped our sky. The very notion of humanity as a truly isolated species, developing in a pristine, untouched cosmic environment, would be utterly dismantled. The implications extend to our understanding of science itself. If a major celestial body in our own solar system is artificial, it means our current astrophysical models are fundamentally incomplete. Perhaps even profoundly mistaken about the processes governing planetary formation and evolution, it would force a paradigm shift, a re-evaluation of every natural anomaly we observe elsewhere in the cosmos. Could other moons or even planets harbour similar secrets? The very frameworks of geology, astronomy and biology would need to be re-examined through a new, more expansive lens, one that accounts for the possibility of cosmic engineering. Furthermore, the existence of an artificial moon would raise profound philosophical questions about agency and destiny. Are we simply an experiment, nurtured by an unseen hand? Does our apparent freedom to explore and develop come with a silent, unseen leash? The psychological impact on humanity could be immense, oscillating between feelings of awe and vulnerability, of being part of a grander design yet also potentially a subject of cosmic observation or even manipulation. It could spark a new era of existential inquiry, propelling us to look not just at the stars but through them, seeking the hidden architects of our reality. The scientific community's resistance to such a radical idea is understandable. It requires a leap of faith beyond empirical evidence into the realm of the truly unknown, and a willingness to confront implications that could overturn centuries of established thought. Yet, the persistent collection of anomalies, the bell-like ringing, the low density, the perfect eclipse, the precise orbit, the shallow craters, and the strange chemistry, continues to accumulate. For those willing to connect these irrefutable clues, they paint a picture not of a random rock but of a masterwork of engineering, a silent testament to an intelligence that reshaped our very sky. The moon, our familiar constant companion, may in fact be the most profound and unsettling secret of our solar system, a monument to an alien presence that has been watching us from the beginning. We have presented a compelling dossier of lunar anomalies, the perplexing seismic echoes, the unnaturally low density, the uncanny precision of solar eclipses, the improbably stable orbit, the shallow impact craters, and the baffling chemical composition. These are not minor discrepancies, they are fundamental characteristics that stubbornly resist full integration into conventional models of planetary formation. Yet, despite the accumulating weight of these irrefutable clues, mainstream science largely adheres to its established narratives, often dismissing alternative explanations as fringe theories. This phenomenon, which we term the scientific blind spot, is not necessarily born of malice, but rather a complex interplay of scientific methodology, institutional inertia, and perhaps a deep-seated human reluctance to confront truly paradigm-shattering truths. The scientific method at its core is built on skepticism and reproducible evidence. Any extraordinary claim, such as an artificial moon, demands extraordinary proof. The current data, while anomalous, is largely circumstantial. While the moon rings like a bell and its density is low, no direct evidence, no alien inscription, no internal structural beams, no clear technological signature has been found. Scientists, operating within a rigorous framework, are trained to seek the most parsimonious explanation, the one that requires the fewest new assumptions and aligns best with known physics. In this context, even convoluted refinements of the giant impact hypothesis are often preferred over invoking an unknown, highly advanced civilization. This preference for existing paradigms is further reinforced by institutional inertia. Scientific research is a vast, interconnected enterprise, driven by established theories, peer-reviewed publications, and funding structures that favour incremental advancements within accepted frameworks. To openly embrace a hypothesis as radical as an artificial moon would not only challenge individual careers, but could destabilise entire fields of study. It would require a wholesale re-evaluation of textbooks, research programs, and observational strategies. This is a formidable barrier, making truly revolutionary shifts in scientific thought rare and often contentious, even when compelling evidence emerges. Moreover, there's a psychological dimension to this blind spot. For centuries, humanity has understood its world and its celestial neighbours through the lens of natural processes. To suddenly confront the possibility that one of our most ancient and familiar cosmic objects is a deliberate construct from an advanced intelligence would be a profoundly unsettling revelation. It challenges our sense of uniqueness, our understanding of cosmic evolution, and perhaps even our perceived safety in the universe. Such a truth could evoke a spectrum of reactions, from existential awe to deep-seated fear, emotions that science, by its objective nature, is ill-equipped to handle. It is easier, and perhaps more comfortable, to explain away anomalies than to accept a truth that changes everything. Consider the historical precedent. For centuries, the Earth was believed to be the centre of the universe. When Copernicus and Galileo presented heliocentric models, they faced immense resistance, not only from religious institutions, but from the scientific orthodoxy of their time. The idea was too radical, too challenging to established thought. Similarly, the concept of continental drift was dismissed for decades before plate tectonics finally became accepted. Major paradigm shifts are rarely smooth. They are often met with skepticism, ridicule, and a slow, grudging acceptance as overwhelming evidence finally breaks through. The hollow moon hypothesis currently occupies this space on the fringe. While it offers elegant solutions to the collection of lunar anomalies, it lacks the direct, undeniable evidence that would compel mainstream scientific acceptance. Without a probe drilling kilometers into the lunar surface to confirm a void or definitive proof of advanced materials, the theory remains in the realm of speculation. Yet, the persistent dismissal of the anomalies themselves, the tendency to compartmentalize and offer separate, often strained natural explanations for each one, rather than considering their collective implications, suggests a deliberate avoidance of the obvious pattern. For critics of official science, this isn't just a blind spot, it's a cover-up, or at least a willful ignorance driven by a fear of the unknown. They argue that the very structures of scientific inquiry, designed for rigour, can sometimes become prisons of thought, preventing the exploration of truly revolutionary ideas. The data from Apollo, the low density, the perfect eclipse, these are not fabrications. They are recorded facts that, when viewed through an unbiased lens, cry out for an explanation beyond the conventional. The scientific blind spot concerning the moon's anomalies isn't necessarily a conspiracy, but perhaps a testament to the limitations of human perception and the immense power of established dogma. It highlights the tension between cautious, incremental scientific progress and the breathtaking possibilities that lie just beyond our current understanding. The moon hangs above us, a constant reminder that the universe holds secrets far more profound than we often allow ourselves to imagine, patiently waiting for us to shed our intellectual biases and truly see what is right before our eyes. Its silence is not just cosmic, it is the silence of an ignored truth, a colossal riddle whose answer may redefine everything we know. We began this journey by challenging the familiar, by asking if our silent, luminous companion, the moon, might be more than the barren rock we have always assumed. We've meticulously gathered the irrefutable clues that collectively paint a picture far stranger than any conventional astrophysics model could comfortably accommodate. From the Apollo mission's jarring revelation that the moon rings like a bell, vibrating for hours after an impact, to its inexplicably low density for an object of its size, every piece of data has chipped away at the edifice of natural formation. We've gazed at the perfect angular alignment of the solar eclipse, an optical miracle that seems too precise to be mere chance, and pondered the uncanny stability of its orbit, a celestial ballet performed with unnatural grace. The shallow depths of its impact craters, suggesting an incredibly resilient outer shell, and the baffling chemical signatures found in lunar samples further deepen the mystery. These are not isolated anomalies. They are a chorus of peculiarities, each one harmonizing with the audacious proposition that the moon is not a cosmic accident, but a profound artificial construct. Now, as we stand at the precipice of our inquiry, reflecting on these amassed contradictions, the central question echoes with renewed force. What if official science, in its dedication to empirical rigor and established paradigms, is simply looking in the wrong direction, or perhaps deliberately avoiding the most uncomfortable truth. The reluctance to fully engage with the collective weight of these anomalies, to piece together the mosaic they form, represents a profound scientific blind spot. It's a preference for incremental adjustments to existing theories, even when those adjustments become increasingly complex and improbable, over the acceptance of a paradigm shift that could redefine. This isn't necessarily a failure of intellect, but perhaps a testament to the sheer psychological and institutional inertia that resists any truth too grand, too ancient, or too alien to fit comfortably into our current worldview. The possibility of a hollow, artificial moon forces us to confront an exhilarating and terrifying vision of the universe. If our moon is indeed an engineered artifact, it implies an intelligence of unimaginable scope and antiquity. This would mean that Earth, far from being a secluded Eden of nascent life, has been part of a grander cosmic narrative for billions of years. Our entire history, from the first single-celled organisms to the rise of complex civilizations, may have unfolded under the watchful gaze of a colossal silent sentinel, a monumental testament to an alien presence that shaped our very sky. This would shatter our illusion of cosmic solitude, inviting us to imagine a universe not just teeming with life, but perhaps with ancient architects and celestial engineers, capable of orchestrating planetary systems for purposes we can only begin to fathom. What then are the philosophical implications of such a revelation for humanity? The sense of wonder, of awe, would be immense as we confront the tangible proof of an intelligence that transcends our wildest dreams. But alongside this wonder, a profound vulnerability would emerge. If the moon is artificial, then who built it? What are their intentions? Are they still here, observing us from within? The very fabric of our scientific, religious, and philosophical frameworks would unravel, forcing a re-evaluation of every foundational belief. We would no longer be masters of our own cosmic narrative, but characters in a much older, infinitely more complex story. The moon would transform from a symbol of natural beauty and romantic inspiration into a constant, silent reminder of our precarious position, a monument to an alien design, a potential prison, or a carefully crafted cradle. This intellectual journey, however, is not about fear, but about the relentless pursuit of truth, wherever it may lead. It's about daring to ask uncomfortable questions and to consider answers that lie beyond the comfortable confines of convention. The anomalies of the moon are not going away. They remain etched in seismic data, calculated in density figures, observed in orbital mechanics, and analysed in chemical compositions. They are the universe whispering a secret, a riddle waiting to be solved, and the solution, however radical, promises to unlock a deeper, more profound understanding of reality itself. Perhaps the true purpose of the moon's enigmatic presence is not to hide a secret, but to act as a cosmic mirror, reflecting our own intellectual limitations and our innate resistance to truths that challenge our perceived centrality. It asks us, are we truly ready to know? Are we willing to shed the comfort of familiar narratives and embrace a universe far more astonishing and perhaps more unsettling than we have ever dared to imagine? The moon, this celestial body of profound paradox, serves as a catalyst for a new enlightenment, urging us to look beyond the obvious, to listen to the echoes of forgotten histories, and to consider that the greatest mysteries are often hidden in plain sight, masquerading as the mundane. In the end, whether the moon is a natural wonder or an artificial marvel, its existence undeniably continues to shape our world, both physically and existentially. It stabilizes our planet, governs our tides, and inspires our quest for knowledge. But if even a fraction of the irrefutable clues we've explored point towards an engineered origin, then our relationship with the cosmos transforms. We cease to be merely inhabitants of a natural world and become potential subjects within a grand, ancient design. The moon, our constant companion, might then be the most compelling evidence that the universe is not a silent, empty canvas, but a meticulously crafted stage, and we, humanity, are simply players in a drama far older and more profound than we ever conceived. Its luminous face, often taken for granted, conceals a story that, if truly understood, would forever alter our perception of reality, unveiling a universe where the line between natural and artificial blurs and the silence of space is punctuated by the echoes of an unimaginable past. The moon waits, eternally patient, for us to finally grasp the magnitude of its silent, enduring secret.